Okay, this is Geometry 4.6. So, we're going to start working with right triangles in this section. And one of the important sides, and a side that people often get messed up, is the hypotenuse. So I've got this beautiful picture for you with the hypotenuse, or hypotenuse. I'm not quite sure how to say it, but hopefully that will help you remember the hypotenuse, to imagine a hippo laying on the diagonal side. Okay, so here's the actual picture. So the hypotenuse is the diagonal one, and the two just straight ones are my legs. The hypotenuse is always across from the right angle. The right angle always points to the hypotenuse. Okay, so here's our hypotenuse leg theorem, which, for those of you that asked about an ASS theorem, no, we don't have an ASS theorem, but we do have a hypotenuse leg theorem, which is essentially ASS, but it's a specific one. So this says if the triangles are both right angles and a leg is congruent, so that's in the blue, and the hypotenuses are congruent, then the triangles are congruent. So here's an example. We're going to skip to our got it problem though. It says to prove that triangle PRS is congruent to triangle RPQ. So I have my given, so angle PRS and angle RPQ are right angles, and SP is congruent to QR. That's an R, and that's my given. So if they're both right angles, then I have right triangles. And I can use reflexive to say that PR is congruent to PR. So then I've got my hypotenuse is congruent, and I've got my legs congruent, and they're both right triangles. So now I can say that triangle PRS is congruent to triangle RPQ by HL, hypotenuse leg. Alrighty, here's another proof for us. So I'm going to write my given first. So CD is congruent to EA, and AD is the perpendicular bisector of CE. So we can't really use that first thing, that CD is congruent to EA, right? It's already marked on my picture. Not much I can really do with it. But I need to somehow use that AD is a perpendicular bisector of CE. So already they've drawn in the right angle, and I also know then this must also be a right angle. So I should first say that, right? So angle CBD and angle EBA are right angles, and that is the definition of perpendicular. The other part of that given that I didn't use is the bisector. So remember, bisector means that it splits it into two equal parts. So I can say CB is congruent to BE, and that's by the definition of bisector. Sort of running out of room down here, but now I can say triangle CBD is congruent to triangle EBA by HL. And there's your homework.